There we go. All right, so in physics class, you guys have done a great job. You've caught up on all your work, so you get a bonus. This is the talk that I give at the cons when I go to them. 50 years of SETI, where is everybody? SETI is the search for extraterrestrial intelligence. Leon. Oh, now my clicker's not working. Isn't that great? Here, let me walk over here and click on it. You know that. We'll talk about that. Let's get to the first slide. So, this has always been something. I wonder if this works now. There it is. Okay, just had to get focused on the screen. So this is always something that's intrigued me. And it starts with the Fermi hypothesis. Enrico Fermi was like this really brilliant guy back during the Manhattan Project. He was a nuclear physicist, so he's close to my heart, to say the least. Enrico had a really interesting way of cutting to the chase on anything you talked to him about. There was one story about him where they set off an atomic bomb, and he had several sheets of paper that were of different sizes, and when the blast came through at the site where everybody was observing, he let go of the piece of paper and he watched the paper fall to the ground and said, "That's about 14 kilotons." And everybody said, "Enrico, you're crazy." So then they took all the data, all the blast data from all the sensors, and then they went and ran it through supercomputers for 2 weeks or something, because this is, after all, early 50s we're talking about. And sure enough, the computer comes back and it's like 14.2 kilotons. And they're like, "How did you know that?" It's like, "Well, you know, just do some wind calculations, you know, drop a few sheets of paper, you can figure it out." And so that's the kind of guy he was. Everybody marveled at just how brilliant he was and how he was able to do these back-of-the-envelope type of calculations. So one day, literally everybody's sitting around the lunch counter at the Manhattan Project. We're talking about aliens. And they're going, you know, what would alien technology look like? You know, how come we haven't heard from them? Are we not communicating the right way? And Enrico just goes, well, they're not there. And everybody's going, all right, Fermi, what's the deal now? It's like if they were already there, or you know, if they were there, then they'd already be here. And the logic goes like this. The galaxy is on the order of 12 billion years old. And if any civilization even got a 1,000-year head start on us, which is the blink of an eye over 12 billion years, right? Then they'd already be here. Captain Kirk would already be parked overhead with the starship coming with his envoys to talk to us. So the fact that nobody was here, Fermi argued, tells us that there's nobody out there. Nobody, at least on the same order of advancement that we are. That's not a comfortable thing to think about. That seems like a really cheesy way to say that there's nobody out there, but it's a pretty impressive argument the longer you sit around and think about it. So with that, I made this talk, and I've given it now to all these cons for the last 6-7 years now. So this is one of my staples. Now you guys get it for free. Not for free, right? You're paying to be here. But let's start with some basics. And this helps with your physics too, right? The universe is said to be 13.8 billion years old. We found out in the talk yesterday that it's 13.8 plus or minus 0.05 billion years now, according to that one lady's estimate, right? The Milky Way galaxy, which still contains first-generation stars, is thought to have formed 10 to 12 billion years ago. Let's say 10 billion, just to be conservative. And the Earth is 4.5 billion years old. Life began on Earth and developed into a technological society. Life began at about 3.5, 3.6 billion years ago. So we've had life on this Earth for about 3.5 billion years. This is from my singularity talk. This is actually from a Ray Kurzweil book that he wrote about singularity. And this shows the progression of advancement according to him. And you see that it takes a good 2 billion years just to get to multicellular organisms. But you get to some knee on this exponential curve and things just blow up. As soon as any form of intelligence starts to take hold, the technological curve is just bam, it's there. So again, we're looking at about a 4 billion year old planet. Somebody should have gotten a head start on us. And if they were even 1,000 years ahead, then they'd already beat it. So this is not an easy argument to just dismiss. So key point, we have a 10 billion year old galaxy, and it takes about 5 billion years to make a technologically based planet. So the galaxy has had the potential to have been growing advanced societies for the last 5 or 6 billion years. There are upwards of 100 billion star systems in our galaxy. That number goes up with time. We used to think there were somewhere around 10 billion stars in the Milky Way. And then as soon as Hubble came out, we realized, oh, shit, there's 10 times as many stars in our own galaxy as we realized. Now, the next generation of telescopes, about to go online, that's probably going to increase that number even more by another factor of 10. But that's okay. We'll stay conservative and we'll stay with 100 billion. So where is everybody? The size and age of the universe incline us to believe that many technologically advanced civilizations must exist. However, this belief seems logically inconsistent with our lack of observational evidence to support it. Either the initial assumption is incorrect and technologically advanced intelligent life is much rarer than we believe, or current observations are incomplete. We simply have not detected them. Our search methodologies are flawed, and we're not searching for the correct indicators. That's from Wikipedia. That breaks down for me to 5 questions. Is anyone out there? If they are out there, how's our hearing? Are we actually looking for the right things? And we've got to put Fermi argument in there. Why aren't they already here? And then there's another possibility, they're here and they're actively hiding from us. So 1, is there anybody out there? That's the rarity question. Presumes the principle of mediocrity. The principle serves us well in physical observation, but could be a fallacy when searching for intelligent life. Put another way, assume you're the only smart person in the world. You might want to believe, even assume, others like you exist, but that doesn't mean they do. If you're alone, you're the first smart person there is, you're going to go, hey, where are my peeps? They may not be out there. It's going to happen to somebody. The question is it happening to us? How's our hearing? I love this graph. I've had it since the first time I started doing this talk. This is from Sky and Telescope. It shows you all of the different SETI programs out there. It's a 3-dimensional plot. Your y-axis, if you will, is relative depth into space. Your x-axis is fraction of the sky. So you can see that a lot of these surveys only cover maybe half of the whole sky. And then your z-axis going into the graph is your frequency that you can scan over, your radio frequency that you can scan over. There's a lot of empty holes in this graph when you look at it. But that's not the punchline. That's not the only punchline. Aside from the fact that there are a lot of empty holes in this graph, the 2 biggest pieces, the Allen Telescope Array and the Omnidirectional Search System, never came online. The Allen Telescope Array got done about 20%, got about 20% finished, and then it ran out of funding. Congress decided they weren't going to support it anymore. That would be bad enough if you only had 20% of its capability, but to keep going and to try to keep building this thing up to what it was originally supposed to be, they're contracting out to the military now. And most of the time spent on the Allen Telescope Array is looking for satellites for the Air Force. So they're contracting their time out just to keep this project alive, which means they only get to spend maybe 10% of their time actually looking for aliens. So just remove this part of the picture, remove that part of the picture, and this is what we've been looking for. This is how we've been listening. There's a whole lot of empty space in that graph. Just to sum that up, how's our hearing? Our hearing sucks. That's the deal there. So are we actually looking for the right things? Remember that communication within our civilization has been based until recently on broadcast radio communications. This was the original idea behind SETI. Get some radio telescopes, start listening. We project information out into space all the time via TV and radio. Other civilizations must be doing that. But we don't do that anymore, do we? Telephones don't emit radio signals, neither does the internet. We ourselves may only transmit in any real volume for 60 years or so. Because we're getting away from television. We're going to streaming media. Why wouldn't other aliens do similar things? So the idea that you would be able to hear them through radio may have been a flawed idea from the very beginning. Our civilization is also based on electrical distribution and fossil fuels. What if this technology isn't the technology base for other civilizations? I remember way back when, in the 80s, there was a popular science article about something called fluidics. The Air Force was working on it. And it's the whole electronics is completely analogous to water flowing through a pipe thing, right? They tried to make chips that didn't actually work on electricity, but flowing fluid. Pressure is voltage, current is current, as in flow, and resistance is how big the pipe is. But theoretically, you could design a circuit that didn't work on electronics at all. And why were they doing it? The Air Force was doing it because they wanted to put these chips in their fighter jets, and that whole electromagnetic pulse from nuclear war, somebody asked about earlier, it wouldn't be susceptible to that anymore. So they were working on a completely new type of technology. What if that had been the technology curve for some of the aliens in question? Maybe not everybody uses electronics. Why aren't they already here? Now we're to the Fermi argument. Well, the first thing you have to realize is the question presumes that colonization or exploration is needed or desirable. You know, this is the way we used to think, even in the 50s, and 60s, and 70s. You know, Bonanza was a big TV show, right? Everybody's going out west and exploring and colonizing. But that may not be the way that life works for a whole lot of other people in the universe or in the galaxy. Now here's the one that really hurts me to bring up, but I think it's one you've got to consider. It may also be that the speed of light is really the universal speed limit. There are no wormholes, there are no warp drives that you can actually send somebody through or use or utilize to get somebody here. This would severely limit our drop-in visits from any neighbors. Even if we had neighbors just 4 light years away, you know, you're talking about an 8-year round trip just to come over for a visit. That still doesn't explain why they haven't called, though, right? Why they couldn't send a radio transmission or something. Are they hiding from us would be the next question. So why haven't they even called? Why haven't even they tried to communicate with us via radio or something? They could literally be hiding from us. Fear is often a big motivator in our own society, but this might be especially true for a society made up of non-predators. I mean, you know, it's been a while, but when I was a kid and I used to go deer hunting with Dad, you know, there was something very, very profound in that. You'd be out in the woods, you step on a twig, and that head would go up on that deer, and you knew you had a half a second or that deer was gone. You won't go see anything but its butt running down the woods, right? So if you were in a society that was based up of herbivores and they weren't predatory members of your food chain that became advanced, you would not even have a mental framework, a mindset to want to talk to somebody that was potentially violent. Your whole world would be about avoidance. Contact with a new race has easily demonstrated a capacity, for violence, would be a daunting prospect. Based on their own society, the aliens may have simply decided that even an exchange of ideas would not be in their best interest with us. We're just too violent, we're just too mean, we're just too base. Why the hell would they want to talk to us? At best, they may feel like there's nothing in it for them. And then there's another idea that I think is very important to bring up. Somebody brought it up earlier this morning. It's the concept of the Dyson sphere. The Dyson sphere is a result of a thought experiment by the physicist and mathematician Freeman Dyson. It's named after him. When he realized that all technological civilizations constantly increase their demand for energy. He reasoned that if our civilization expanded energy needs long enough, there would come a time when it would demand the total energy output of its sun. He processed a system of orbiting structures which he referred to initially as a shell. It was designed to intercept and collect all energy produced by the sun. So he's literally talking about building a box around your planet that goes beyond your own, or around your sun that goes beyond your own planet. And capturing all the solar radiation. It would also capture any radiation you emitted from the planet, right? For communications or whatever. Not only that, but it's if somebody were to do this, to capture their own solar radiation for their society, they'd go dark. They'd be a dark spot in the sky. We wouldn't even know to look in that direction. So, literally, the places we're looking for, might not even be on our radar. So should we despair? Recap here. What if they don't want to talk to us? Such an example of that would be the Prime Directive in Star Trek. Just because they don't think they should interfere with our development. Or they actually fear us damaging their society, bringing violent ideas and things that they don't think are going to be good for their own masses. So, what if they can't talk to us? That's another possibility. Either deliberately, because they put a Dyson sphere around their own planet, or they don't use electromagnetic transmissions because they don't base their entire society on electronics. And then there's inadvertently not being able to talk to us. Famine, pestilence, and war. Things happen within your own world that you've got to deal with. You don't always have time to look outwards, even in a technologically advanced society. One of the things that limits us, we have nuclear treaties. We can't send nuclear-powered satellites into orbit. I mean, we can, small nuclear batteries, but there's a real limit on it because we don't trust each other. So again, that limits how much radiation we're spewing out into space because we're not getting outside of the atmosphere with really powerful transmitters. So lots of times it could be your own treaties with your own neighbors that keep you from doing things that would make you really visible out in space. Our own mistrust of each other, falls into that category. So in the final analysis, I think there are two major problems that can pretty much explain everything. Our hearing sucks. It's not nearly as good as we'd like to believe. And faster than light travel may not even be a real possibility. It may not even be, a viable option for anybody. So they're not going to physically drop in and visit us, and we're not listening to the right things to hear them when they're trying to talk to us. Number two would be we're simply not that interesting in the first place. and contact with us would be pointless or even harmful from ET's point of view. That was literally the first year that I gave this talk. Now we're in the bonus material because I can go a lot faster. You know, it used to take me an hour just to get through that much. Now we're into year 2, and the slides that I added in the second, third year. Lots of times when you have this discussion, you talk about the Drake equation. He kind of even was the father of the whole SETI program to begin with, but Drake basically tried to pin a formula that would take the probability of other advanced societies existing. He put a lot of fractions in there. This is just the number of average stars that are formed every year within the Milky Way. So this is the production rate, if you will, of possible new societies. And then this number is multiplied by all these fractions. Fraction of those stars that have planets. Thanks to Kepler, we know that just about every star we look at, we can resolve it. It's got planets around it. So this number is getting very close to 1. Average number of planets that could potentially support life per star. Fraction of the planets that could support life that actually develop life at some point. So average number of planets around a star. How many of those actually give birth to life? Then the fraction of the planets with life that actually go on to develop intelligent life. Fraction of civilizations that develop a technology that releases detectable signs of their existence into space. And then finally, you've got to multiply all those numbers by the length of time that that civilization will exist and be audible. You could actually hear. The funny thing about taking a big number and multiplying it by a lot of fractions without knowing what a lot of those numbers are, and without even knowing what kind of estimate you're looking for, depending on who you ask, you can get anything from 1 to 3.6 or 36.4 million. So depending on who you ask, there could be 36.4 million advanced societies within our own galaxy. This is all within our own galaxy. So the Drake equation is interesting. Everybody brings it up when we have this discussion, but there's a really wide range of options there as far as what might actually be happening. So, of course, having brought that up, I had to put my own numbers in. When I did the calculation myself, based on the Kepler data, you know, this most recent, I assumed a 1,000-year lifetime. That tends to be maybe the thing that people quibble with me the most about. But I figured that it's on the order of 1,000 civilizations within our own galaxy. Advanced civilizations within our own galaxy. So now you still got to ask, why aren't they talking to us? Wanted a number to go with, so I came up with one. Sort of in the middle, closer to the bottom than the top. 1,000's a lot closer to 1 than 36 million. But that's my idea of a reasonable estimate. So I take this a step further. I say, okay, 1,000 civilizations out there. I came up with something I called the sphere of isolation, which basically is just taking the entire volume of the galaxy and dividing it by 1,000 civilizations. It says, how big of a chunk of space, on average, would each civilization have if there were 1,000 of them in the Milky Way? So I got a number for that. Then I said, okay, that would be 1,000. The average distance, you know, between two civilizations ends up being 1,000 light years apart from each other. You know, I assume the 6 nearest neighbors. I assume, you know, a nice even distribution, which of course is probably a fairly weak assumption because we live out in the boonies compared to the galactic core, right? But let's say on average that we are a big representative of that. We're not on the complete outer edge, but we're not in the core either. So, nice even distribution. I said, you know, if there's a nice even distribution through the disk of the galaxy, we should have 6 neighbors that are within that 1,000-year radius of us. Why did I do all this? Because it's all just playing with numbers if you don't have anything to back it up, right? But I wanted to figure out what was going on and why we've not heard from them. So these are the best numbers I could come up with. 1,000 light years apart, 6 neighbors. Each civilization has a lifetime of 1,000 years. Each civilization is transmitting for 100 years. And let's say that there's a 10% chance of detection. If you put those numbers in and do simple statistics on it, there's only a 47% chance that we'd ever hear anybody. All that said, here's your 2016 update. Still, as time went by, I could do the talk faster and faster and get through it. This one made me really happy. This is the news I broke when we were Dragon Con last time I talked there. There's something out there called the alien megastructure. There is a star called Katie star, named after the astronomer that found it. And it's got this weird dimming and brightening cycle to it that can't be explained by just normal planetary objects going around the star in some predictable orbit. The theory was that it's the beginnings of the Dyson sphere. It's called a Dyson swarm because it's not a complete sphere, but they're putting a whole lot of big satellites out there around their sun, and they're trying to capture as much solar radiation as they can and beaming it back to their planet. And in doing so, it might only be 20%, but it's covering up, say 20% of the light from that sun. And it's doing it in a way that just doesn't make sense in terms of something natural occurring. This was the story in 2016. The astronomers that reported it, of course, had to be low-key. The last thing you want to do as a scientist talking to the public is say, oh yeah, we're excited, we think aliens are there, because next thing you know, USA Today is running a report, the scientist says there's aliens in this star system. So they have to be low-key. They tried not to be overly excited about it. And actually, the last thing I heard about this, I think about 8 months back, is they said, yeah, we've looked at the data even closer, and now we've decided that it could be nothing but a really big asteroid cloud. So it doesn't have to actually be something artificial. I almost said man-made, but man-made wouldn't be appropriate, right? They're saying that now it probably could be nothing but a really big asteroid swarm around the outside of the sun. Now, this was the next update for the next year, for the next time I gave this talk. There's a new program out called Breakthrough Listen. It has improved our hearing tremendously. Breakthrough Listen will obtain data over a 10-year period from a network of the world's most powerful radio and optical telescopes to yield vast full sky signal monitoring. It will collect more data in one day than previously had been collected in 1 year. Search capability will be 50 times more sensitive, cover 10 times more of the sky, 5 times more of the radio spectrum, and its speed's 100 times faster. So this is a game changer. Suddenly we're taking data way faster than we ever took it before. I don't have anything yet, but the data's flowing in. And the other thing about that is you've got to collect the data with the radio telescopes, but then you've got to crunch the numbers, right? You've got to take the noise out, you've got to run it through a supercomputer, you've got to then look for a signal that's not natural, that varies in some way that would make sense, that's not just a star giving off infrared radiation or ultraviolet radiation or radio frequencies, right? So you've got to cut out all the natural objects we already know about, like pulsars and things like that. So there's taking the data, and then there's crunching the numbers. So this is on the horizon, but it's not surprising that we haven't heard anything from them yet, really. So that's the whole talk. So now, if there's any questions, you guys sat there nice and quiet. Behaved really well. Would that you would have done that for my whole class. Any questions or anything? Good?
Isn't it possible, even if we were only 200 years older, or 200 years older than the next civilization,
Uh-huh.
that we also wouldn't be able to hear from them either, because they're not there yet?
Absolutely. That's part of that 10% probability of hearing somebody else. Is if you got a 1,000-year lifetime and you only transmit in the radio spectrum due to your technology curve for 10% of that time, which I think is a fairly reasonable number, right? Because, like I say, we're about to go dark. We're about to stop using TV transmitters, really. I mean, we've already gone to digital, and so there are arguments that digital signals can't carry the same way that analog signals could, and will degrade, and you literally will see nothing but static coming from our planet, say, 10, 20 light years out. So yeah, it's entirely possible that they could be 200 years ahead of us, or we could be 200 years ahead of them, and they've gone completely dark. We're not listening for the right things. They're not communicating in ways that we can hear them, and vice versa. So yeah, that's absolutely true. Anybody else? Well, I guess we'll call that a day then.